So we're going to continue working section 5.1. We're going to build on our calculation from just a minute ago. We're going to calculate sigma squared. Now, you might remember sigma squared. It might be some familiar notation. Mostly what we use is the square root of sigma squared, which is sigma, which is our standard deviation. Well, sigma squared is calculated this way. It's going to be the sum of P of X times X minus mu squared. So that's going to be your variance from a probability distribution. Variance. So we'll practice calculating that variance. We'll go back to our work with rolling a pair of dice and see if we can't calculate the variance there. And then we'll take a look at some applications of the variance standard deviation. So let's go back to our handout on, or excuse me, our Google Sheets on probabilities. And I should have another column here that we didn't use yet. And that's the column we need to calculate our P of X times X minus mu squared, and then sum that up to get the variance. So let's see if we can't mimic this calculation. Remember, I want to take P of X times X minus mu. Now, in our first example here, we've already calculated mu. That's the mean. And we know that value to be 7 from our work in the first part of this class. So let's follow along, and I'll try and type this in real slow here. So put your cursor in column F, row 7, type in equals, and I want to do P of X, which is this column, so click there, times, so an asterisk. I'm not sure I'd suggest using product here or not. I think I'd suggest just using an asterisk. Left parenthesis, so D7 times left parenthesis. And then I need X minus mu. Now, mu for us is a 7. And when we do these calculations, I'm just going to type in these numbers. Don't do the click and drag if you're not typing in that number. You need to type in the mu there. Otherwise, the formula is not going to work like you think. So D7 times parentheses A7. So click that first column, 7th row, minus 7. So basically that's X minus mu for the first row. Right parenthesis. And then shift 6 to get that up arrow, because we're going to square it. So it should look just like this. Let me see if I can zoom in a little bit for you. Make that a little bit bigger. There you go. D7 times parentheses A7 minus 7 squared. Now that 7 is coming from the mean that we calculated in the first part of this class. When you hit enter, you should get 0.6944. Now, if you're struggling with that, I can do that again. So let me go back. I'll just delete that. It's going to go a little faster this time, but still going to repeat it. So I want equals. Then click the 2 underneath the X times left parenthesis. Actually, no, it's not the left. I'm sorry, I screwed that up. Equals P of X. So D7, then times parentheses A7 minus 7 squared. And then we're going to copy that and drag that all the way down to the 12th row of this table. Don't take it all the way to the bottom because I don't want the bottom one. Just down to here. The sum of this column should be the variance. So double check yourself that the second value that you got in this table is 0.8889 and then 0.7500, etc. When we sum this, that'll be our variance. In fact, when I even type in the equals, it says, oh, do you want to sum? So I'll just click and say, sure. Sum column F from row 17 to from row 7 to 17. Let me do that again. Equals sum. When you type in sum in the left parenthesis, then you should just be able to click and drag and it'll fill in the comments for you. So that's your variance.
I have a quick question.
Yeah, throw that.
What does the M stand for, or the MU?
That's mu. That's the mean.
So that's the mean. So we're subtracting the mean from the mean?
No, you're subtracting the mean from the value of the variable here. So the value of the variable, you know, could be any one of these. And as part of your calculation, you're going to do x minus mu squared. So I guess in this case, if you'd like, what I could do is I could put in x minus 7 because 7 is the mean.
Got it.
I just put in mu out of habit because mu is going to be in that formula in general.
Right.
That it's going to be the average or the expected value.
Yeah, I think I just got confused because of the A7 on the first one.
Okay. All right.
I thought it was like we're subtracting mean from mean.
Are these numbers coming through for you okay?
Yeah, they're good.
Okay, perfect, perfect. Now keep in mind when we get down to the bottom here, that's the variance. It's not the standard deviation yet. To get the standard deviation, what do I have to do to the variance?
Find the square root of it.
Yeah, take the square root of it. Thank you both. So let's take the square root of that. Let's see, that's my variance. So over here, let me do equals SQRT, and it starts recognizing what you want. You hit enter and it'll put in a left parenthesis for you, asking you to take the square root. Just click that cell next to it and press enter. So there's your standard deviation right there, 2.415, etc.
Can you do that again?
Sure. So I'll hit delete here to start from fresh. Go into this next to the variance, type in equals, and we want the square root. So just start typing in the letters for square root, SQR. And it says, oh, you want the positive square root of a number. At least it does for me. If it doesn't for you, then just keep on typing SQRT and then a left parenthesis. And then you can click whatever cell you want to take the square root of. In this case, it's the variance there to the left. Right parenthesis, and then bam. 0.241. Nice. Nice. Okay. Are we good with that one? You able to get the standard deviation? Let's apply the standard deviation. Now, back when we were dealing with actual data, not probability distributions, what did the standard deviation tell us? Do you remember what the standard deviation would tell us?
How spread apart our data is.
Yeah, Jalen, way to go. How spread apart your data was. How far on average it was from the mean. And it started to help identify what was an unusual value. Was it 2, 3 standard deviations above the mean? Was it 2 or 3 standard deviations below the mean? So, wow, you know, could be any of those. Now, back then and here, anything that's more than 2 standard deviations away from the mean is starting to be either significantly high or significantly low. Those are unusual values. Something that's within 2 standard deviations of the mean, oh, that's a little bit more tall. So let's see what that is for our rolling the dice example. What would be an unusual roll? Now, I'll give you a heads up. We might not get integer values, but that's okay. So let's take a look here. Let me see. I'll do that right here. I want to do the mean minus 2 sigma and the mean plus 2 sigma. So I'll write down kind of like a heading for what I'm going to be calculating, but I am going to with exactly what we just said. Mu minus 2 sigma and mu plus 2 sigma. So I'm just showing you what I'm calculating. You don't have to type that in. It's up to you if you want to or not. Get rid of that. So I'll start with the mean. Now all my commands start out with an equals, so I'll have to do equals. The mean was 7 minus 2 times sigma. Now I don't feel like copying that number by hand or writing it in, typing it in by hand. So just click that cell. There you go, 7 minus 2 times sigma. Let's try it again over here. This time I'm going to do 7 plus 2 times sigma. In fact, this time I'm going to get even lazier. I'm not even going to bother to type in the number 7. I'm just going to say, oh, you know what? That's over here. So I'll click my 7 plus 2 times sigma. I should get 11 something is my guess. Okay. Now these aren't integer values. That's okay. There's nothing wrong with those values. But let's understand what they mean and what they're telling us about rolling a pair of dice. Before I do that though, are you able to get these values? Because this will be part of your homework, part of your little quiz assignment. Mu minus 2 sigma, mu plus 2 sigma. Okay. So let's take a look at our values that we get when we roll a pair of dice. Perfect. 12, right? Now, the values that we got when we did mu minus 2 sigma and mu plus 2 sigma fell right in here. What was it, about 2.15 or something like that? Yeah, 2.17 and 11.83. So these encompass our typical values. So our typical values would be all of these. Those are typical values. Are there any unusual values? Significant values that you can get when you roll 2 dice? How about a 12 or a 2? That would be significantly high, and that's significantly low. It's important to notice that 2.17 doesn't go past 2. So the only events that it includes are 3 and up, whereas 11.83, that doesn't quite get to 12. So the only events that it includes are 11 and lower. So those are your two calculations for mu minus 2 sigma and mu plus 2 sigma. And that helps you to identify what's typical and what's not typical. So the atypical rolls with a pair of dice are a 2 and a 12, so-called snake eyes and boxcars, if you're ever at the casino. Are you able to match these calculations on Google Sheets? And do you understand what it's telling you here? Okay, I'll take that as a yes. Thanks for the endorsement. Yeah, so we have significantly high and significantly low values. Now, what I want us to do is I want us to do that kind of calculation for this probability distribution. So we're going to kind of repeat that and try and find out what's significantly high and what's significantly low, if anything, in this table. Let's first understand what it is. So for these exercises, refer to this table, which describes the number of adults in groups of 5 who reported sleepwalking. Now, our author is really good about getting good data, taking it from reputable sources, etc. I just can't believe that if you had 5 people in a group, that there's a 36% chance that one of them is going to sleepwalk, or a 31% chance that 2 of them are going to sleepwalk. It just seems, I don't know. Do you know that many sleepwalkers? I don't. Maybe they're using a definition of sleepwalking that I'm just not familiar with, but it seems really high. In any case, these probabilities, I think, should be on your sheet already. So let's turn our attention there. We got to do 2 things. We got to calculate the mean and standard deviation. So here's your probabilities. I'm going to delete all this stuff here. Thank you, Tia. Yeah, those probabilities do seem kind of high. So there's 2 things we got to calculate. We got to calculate x times p of x. And when we do that and sum them all up, that'll give us the mean. So I'll just write mean here, but it'll actually be the number above. This is the easy part. So equals x asterisk p of x. So column A, row 20, times column B, row 20. And of course, we could have done that one in our head. You're going to get a 0. We can do the second one in our head as well. Let me highlight that so you can take a quick look at it. A20 times B20. That's all there is. And then I'm going to repeat that calculation all the way down. That is if I can scroll to the right spot. To repeat that calculation, grab the corner in the bottom right of the rectangle and drag it down to the 5th cell. What do I got to do from here to get the mean of this distribution? Add them. Thank you, Kelly. So let's add them equals sum, left parenthesis. After you type sum in left parenthesis, you should be able to click and drag all these cells and then hit enter. Why don't you put in the chat what you're getting for me? I want to see that you guys are able to keep up here. Put it to me privately, please. Ali,
have a
Kelly, Noel, Leah, Nicole, Mason, good job. Thank you.
I had a question.
Yeah, please.
I'm typing in equals and then I'm trying to type in sum and like nothing's popping up to click on.
Sometimes it doesn't. But when you type in sum, then type in the left parenthesis. And even if nothing pops up, you should be able to highlight the values that you want summed up.
Okay, yeah, I just did that and it worked. Thank you.
Okay, thank you. All right, let me take a look. Got a few more here. Oh, wow. Somebody's even gotten the mean and standard deviation too. Or, well done. Thank you, Chloe. Katerina, Madeja, well done. Well done. All right, glad to see that we're keeping up. So the mean is 1.48. Now, let's come up to the next column and calculate the variance. So I want P of X times X minus 1.48, oops, squared. Because remember, I'm going to take X minus mu. Mu in this case is 1.48. So I'll just type in that 1.48. In cell D20, let's put in the following command. Equals. P of X is over here in column B. So equals B20, then asterisk, left parenthesis. So B20 times parenthesis X, which is in column A. So A20 minus 1.48, right parenthesis. So minus 1.48, right parenthesis, then shift 6 gives you that up arrow. And I want to square that. All right. So there's that command. When you're ready, press the enter key. And it's going to ask you, do you want to do that all the way down? I'm going to say no. So I want to just click and drag that to particular cells, not all of them. So I'm going to drag that down to row 25 and stop there because I want to total up this column to get the variance. I'm going to put variance right here, and then below that, put standard deviation. So the variance is going to be the sum of this column. You could actually type in sum if you'd like, equals sum of all these numbers, right parenthesis. Kind of a clever way is just to drag this formula to the right, would have done the same thing. So kind of nice. Then I need the square root of this. Let me pause on the standard deviation. I don't want to get going too fast. Are we okay with the standard deviation?
Yeah.
Thank you.
The audio is messed up again.
Am I lagging?
Yeah, the audio is happening like it happened last time.
Yeah, you're like crackly.
Oh, man, I'm sorry. I've seen a couple messages on my computer that said my internet was unstable. I'm not sure what's going on. Maybe because there's 3 of us in the house trying to use the internet. Sorry about that. Let's do the square root. So there's our standard deviation. Highlight that in red. Make it a little bit bolder. And I'll put this one in blue. So between the mean and standard deviation, we want to try and find out the unusual values, the significantly high and significantly low values for this distribution. But the first step is getting these two numbers, the mean and the standard deviation. So I'll pause if there's some question or concern about getting these. Okay. Let's find mu minus 2 sigma and mu plus 2 sigma.
Could you click on D20? I just want to see the formula, like what you entered for that. There you go. It's just a square root of the number above it. No, D20, not 27.
Oh, D20. Oh, my bad.
All right, thank you.
Mhm. So for mu minus 2 sigma, we could type in equals 1.48 minus 2 asterisk, and then don't type in the standard deviation by hand. Just click that. So that's mu minus 2 sigma. Now I'll repeat that for mu plus 2 sigma. This time I'm going to be lazy. I'm not even going to type in 1.48. I'm just going to click the mean minus, excuse me, plus 2 asterisk and then standard deviation.
Is sigma a standard deviation?
Yes. So I'm closing out a few windows to try and see if that helps out the audio at all somehow. So here's our results from 2 standard deviations below and 2 standard deviations above the mean. So let me write that down. So example E, we had 0, 1, 2, 3, 4, and 5. When we looked at mu minus 2 sigma, we got here mu minus 2 sigma, mu plus 2 sigma, put us here and here respectively. Now, can you have negative 0.557 sleepwalkers?
No.
No, you can't. Well, what numbers can we have? 0, 1, 2, 3. Now, 3.517, that was mu plus 2 sigma. So it's these numbers that are in this range. So what's that saying about 4 and 5?
They are significantly high.
Thanks, Don. They're significantly high. Okay. And with that, I think you can answer all the questions here that go with this. Use the range rule of thumb, determine if 4 is significantly high number of sleepwalkers. You know, is 3 a significantly high number, etc. So we can answer all the questions we need to based on this probability distribution. So how are we looking on that? Doing okay?
Yeah.
Yeah.
Good. You know, one other thing that's pretty nice about having these probabilities in Google Sheets like this is that you can quickly answer questions like this. What's the probability of X is greater than or equal to 2? So that would be, let's see, that'd be all 4 of these probabilities. And to get that, all you'd have to do is sum it up. You'd say, okay, equals sum, and then just click the appropriate probabilities. So this is a probability that X is at least 2. Now, if you have probability that X is more than 2, does that change anything? Actually, it does. Does more than 2 actually include 2?
No.
No, it doesn't. So more than 2 really means probably that X is greater than 2. So it would start here with 3, 4, and 5. So if I wanted that probability, the sum of just those 3. So there you go. So it's a difference of does it include or not include the 2. You got to be careful with at least or at most or less than to decide whether or not you're including something or not, because it'll make a difference in your probability calculations. Okay, let me stop things here.